Alright, make sure you're on page 129. On this video, we're going to be looking at modeling using function notation. Essentially, it's what we did in earlier modules. We're going to write an equation that represents a real-world problem, but we're just going to write that equation in function notation form. So let's read the first example here in part A. A lawyer's fee is $180 per hour for his services. How much does the lawyer charge for 5 hours? So we want to read the sentence below. The fee of the lawyer depends on the number of hours he works. So we can see that the independent variable is the hours, the dependent variable is the fee, and we want to let h represent the number of hours. So we're going to use h in our equation instead of x. So you can see below that we're going to use function notation. So instead of using y, we're going to use f. So it's a function that has an h in it, and it's just $180 per hour. So that's where the f of h equals 180 times h. And now we want to answer the question, how much does the lawyer charge for 5 hours? Well, what's really nice about function notation is that we can replace h with 5, because that's what we're looking for. We're looking for when h is 5 hours. And when we replace h with 5 right here at the beginning, we're also going to do that on the right side of the equation. So I see an h, I'm going to replace it with 5. So this notation right here is just telling us we're having a function and we're putting 5 in it this time. So 180 times 5 is $900. And again, we always like to write our final answer as a sentence. The lawyer charges $900 for 5 hours of work. All right, let's go down to part B here. The admission fee at a carnival is $9. Each ride costs $1.75. How much does it cost to go to the carnival, then go on 12 rides? So just to get to the carnival, you have to pay $9, and then it's $1.75 for each ride. So the total cost to go to the carnival depends on the number of rides. You don't ride any rides, you only have to pay the $9. If you ride a whole bunch of rides, you're going to have to pay the $9 plus the $1.75 for each ride. So the dependent variable is the cost, the total cost, and the independent variable is the number of rides, because the cost depends on how many rides. Let r represent the number of rides. So we're going to use r in our equation for our variable. So you can see f of r. And let's think about it. It's $9. I kind of like to put my $9 at the end. It's $9, and then it's $1.75 per ride. So that's the $1.75 plus the $9 it costs just to get into the carnival. The question actually says how much does it cost to go to the carnival and then go on 12 rides. So we're really looking for f of 12. So notice, right, if we look right here, I changed r to 12. So when I see another r in the equation, I'm going to change that r to 12. So we're going to do 1.75 times 12 plus 9. Now we're just going to simplify. So f of 12 is 30. We got to write our nice sentence to describe what we're doing. So it costs $30 to go to the carnival and go on 12 rides. If you would like, you could pause the video right now and do the your turn number 4, or you can do it after the next page. All right, we should be on page 130 now. This is basically the same thing. We're going to write an equation in function notation form for our real-life problem, but then we're going to talk about reasonable domain and range, because a lot of these real-world problems, you can't choose any number to fill in. Like, think back on the problem before with the carnival rides. Could we have said what would be the price to go to the carnival if we had 5.5 rides, if we went on 5.5 rides? No, we can't say that, because you can't go on 5.5 rides. So we would only really be able to pick, integers. We wouldn't have decimals. We can't go on -2 rides, so that wouldn't be a reasonable domain. So that's what we're going to talk a little bit more about in this section. So let's look at example A. Manuel has already sold $20 worth of tickets to pay to the school play. He has 4 tickets left to sell at $2.50 per ticket. Write a function for the total amount collected from the sale. So we want how much money he collects. We know he's already collected the $20, so plus the 20. We're going to use t to represent the number of tickets, so we're going to use f of t, and it's $2.50 per ticket. So let's write it a little nicer over here, not so spread out. F of t equals $2.50. Let me just slide over so I have a little bit more room. $2.50t plus 20. All right, we want to talk about reasonable domain. Well, he only has 4 tickets left, so what could we put in? Remember, domain is our x value, our input. In this case, we don't have an x, we have a t. So what values would make sense for the number of tickets left that he could sell? Well, he could sell 0 more. Maybe he's only sold the $20 and that's it, and no one else wants to buy a ticket. He could sell 1 ticket, 2 tickets, 3 tickets, or 4 tickets. He can't sell 5 tickets because he only has 4 left. He can't sell 3.5 tickets because that's not how tickets work. So this is our domain that you can see over here that the book has written. And then we want to find, well, what's the reasonable range for what we have left for our domain? So remember, range is our output. So if we put in 0, what are we going to get out? So f of 0 equals $2.50 times 0 plus 20. So this would represent if he sold 0 more tickets. Well, f of 0 is 20. So that would be our first range value. Then we would do f of 1 ticket and plug that in. So we get $2.50 times t plus 20. So that's going to be the $22.50. Then we're going to do f of 2, f of 3, f of 4. And those are those values right here. So this is our range. So we have our domain and our range that work for this particular problem. All right, let's go down to part B here. A telephone company charges 25 cents per minute for the first 5 minutes of a call, plus 45 cents connection fee. So that connection fee is no matter how long you talk, you got to pay that 45 cents. Let's write a function for the total cost in dollars of making a call. So we're going to let m represent our input. That's our independent variable, and it's going to represent number of minutes in this problem. So f of m equals 0.25 or 0.25 times m plus the fee that we have to pay, that 45 cents, no matter how long we talk. So if I write my equation over here a little bit nicer, it's 0.25, let's slide over, m plus 0.45. All right, now we need to talk about what a reasonable domain is. So technically, I guess you've got to talk more than 0 minutes. So our first reasonable input would be 1 minute, 2 minutes, 3 minutes, 4 minutes, 5 minutes. I've got to stop at 5 minutes because it says per minute for the first 5 minutes. So these numbers only work for the first 5 minutes. Maybe it goes up after that, maybe it goes down, but it only works for the first 5 minutes. Now, should we just be picking integers? Well, this one's a little trickier, but it seems like they're probably rounding to the closest minute. So though you could talk for 1.5 minutes, they're probably going to round that up to 2 minutes. So the feasible domain, the reasonable domain in this is just 1, 2, 3, 4, 5 minutes. All right, now we need to talk about the reasonable domain. So remember, that's the output. So when we put in 1 into our function, what are we going to get? So 0.25 times 1 plus 0.45. That's going to be 70 cents. So we need our braces. We're going to list 0.70. Now we've got to do f of 2. 0.25 times 2 plus 0.45. It's going to give us 0.95. And we're going to do that for 3, 4, and 5. I'm going to go ahead and calculate those numbers for you, but that's going to be $1.20, $1.45, and $1.70. Alright, so now you need to go on and try your turns 5 and 6. Make sure you write the function equation first, and then come up with the reasonable domain and the reasonable range.